Be looking at rotation and rotation about the origin part 1. So first let's define what a rotation is. So a rotation is a type of rigid motion in which a figure is transformed and turned around a fixed point. So let me do this visually. For example, if this is the center, and if this is our object, and if this is our point, if it goes from this point to this point, then this is called rotation of this particular point. So the rotation is defined by 3 main elements. The first one is the center of rotation. And the second one is the angle of rotation. And the third one is the direction. So the direction could be in the clockwise or counterclockwise direction. And when we say center of rotation, it could be the origin or any other point. On the xy plane, the angle could be 30, 90, 60, 180, and whatnot. And the direction is pretty self-explanatory, but for those of you who don't know, the direction clockwise means in the way the clock rotates. So the clock rotates like this, right? So it goes like this, right? So this is clockwise. Counterclockwise is on the opposite or counter to how the clock works, which is this way. So this is counterclockwise. And the other thing that we need to know about rotation is that it keeps the size and shape exactly the same throughout the motion, okay? So every point on the object moves in a circular path and the shape and size are kept exactly the same. Another one is only the orientation changes. So in this case, the orientation is particularly preserved, but the direction changes. The direction it faces changes. For example, if this particular one faces northeast, then this one might face northwest, okay? So that's how it works. So now let's look at different special scenarios. So for example, if we rotate a particular body 90 degrees counterclockwise, the xy will be turned into minus yx. So to show you this very easily, if we have a point right here with 2, 4, if it's rotated to this point, it becomes minus 4, 2. So this is how it works. The next one is 180 degrees if it's turned in clockwise or counterclockwise. So when it's turned counterclockwise, the x comma y is turned into negative x comma negative y. So this is because when we turn a body 180 degrees, it fully turns around, which basically makes the coordinates negative, okay? So if it was negative, it would be positive. If it's positive, it will be fully negative. Or you can just multiply by negative. You can multiply both the x and y with negative. So now let's see how the angles change depending if it's clockwise or counterclockwise. So if it's clockwise, if it's clockwise, then the angle would be greater than 0. This is because when we turn an angle this way, like this, it will go into the positive direction, so the angle has to be positive. So when it's counterclockwise, theta is less than 0. This is because when the angle goes in this direction, which will make the angle negative. Now let's look at the notation of how we denote rotation. So if r equals rotation and theta is the angle of rotation, then we can define this as r theta equals to x comma y. So this is how we denote basically denote rotation. So now let's do a few examples. So the example says find the image of point A 2, 0 when it's rotated through 30 degrees about the origin. So we are given a point A with 2, 0 and theta is 30 degrees. So we are asked how it looks like when it's rotated about the origin. So let's basically draw the xy plane. XY plane first, we need to define what this particular line looks like, which is 2, 0. So 2, 0 is obviously on the x-axis, so it would look something like this. So This is 2, 0. Okay, so, and let's draw the angle as well. So as you can see, if we draw a straight line from this point right here to this point right here, it wouldn't be a straight line, it would be a curve. So in order to find the length between the x-axis and the, so to find the image of this particular point, then we need to draw a straight line, just like this. It doesn't land on the pointer here, so that means the exact coordinates of this point is not known. So we're just going to denote this as A. Okay, this is A. And any point drawn from the origin is going to be the radius. So this is going to be 2. Okay, so 2, 0 is going to be one of our radius, but this is also our radius, so this is also 2. And we're going to denote this as B. So this point right here is going to be A prime. So A prime is going to be A comma B. So it's gonna, this B is gonna tell us the vertical length, and B is gonna tell us the horizontal length. So let's get started. Let's first solve for A. So A is obviously the x1, so it's cos theta equals adjacent over hypotenuse, which will equal cos theta, which is cos 30. Cos 30 is going to be root 3 over 3, which will equal, adjacent right here is A, and the hypotenuse, as you said, is the radius, so it's 2. So crisscross, we're going to crisscross root 3 times 2. No, before we crisscross, we can cancel these out, and then it's going to be A is root 3. Now let's look at B. So it's going to be sine theta, which is equal to opposite over hypotenuse, which is going to be sine 30 equals and we're going to say 1 over 2. So sine 30 is 1 over 2, which equals to B over 2. So B is equal to 1. So the exact coordinates of this particular point, or the image of A, is going to be root 3 over 2, root 3, 1. So this is how you basically solve problems. We're going to solve other problems in the upcoming video titled Rotation Problems Part 1. Please be on the lookout for that. So yeah, bye guys.